Welcome to System Design Fundamentals, a beginner's guide to building systems that scale from a single laptop to millions of users. Why study system design? Simple architectures break down with millions of users. System design addresses scaling for concurrent users, fault tolerance for system failures, security for distributed infrastructure, and monitoring for debugging and optimization in production. A server is a machine running your application code. When you visit a website, a DNS lookup resolves the domain to an IP address. A request is sent to the server at that IP, and the server returns a response. Latency is the time for one request to travel to the server and back, measured in milliseconds. Lower latency means a faster experience. Throughput is the number of requests the system can handle per second. The ideal goal is low latency and high throughput. Vertical scaling means scaling up or down by adding resources to the same machine. Horizontal scaling, or scaling out in, means adding more machines and distributing the load. This is the go-to approach in production, requiring a load balancer. Clients never talk directly to servers. The load balancer sits in front and routes intelligently. Load balancing distributes traffic across healthy servers. Auto-scaling dynamically adds or removes servers based on real-time load, allowing you to pay only for what you use. Back-of-the-envelope estimation uses approximations to keep the math simple during system design. Use powers of 2 for scale estimations. For example, in a Twitter scenario, a daily load of 100 M daily active users results in 1 B writes and 100 B reads, requiring about 25 servers for the traffic. The CAP theorem states that in any distributed system, you can only guarantee 2 of 3 properties: consistency, availability, and partition tolerance. Since network partitions are inevitable, partition tolerance is non-negotiable. You must choose between consistency or availability. CP, consistency plus partition tolerance, stops accepting writes during a network partition, ensuring no inconsistent data is served. This is essential for banking or payments. AP, availability plus partition tolerance, keeps responding, even if users see slightly stale data temporarily. This works for social media and news feeds. Key takeaways: start simple, then scale with load balancers and fault tolerance. Measure latency and throughput, aiming for low latency and high throughput. Scale horizontally with cost-efficient auto-scaling. Finally, know your CAP trade-off. Partition tolerance is required. Choose CP for financial apps and AP for social platforms.